Okay. All right, well, welcome everybody. We'll get started. Undoubtedly, more folks will join in time. Thank you for joining us today. Thank you for joining us for the second Decarbonization Forum of our 2024-2025 series. This is a part of a series of events designed to inform and engage our campus community about MIT's journey towards decarbonization, which gives us pause and a great opportunity to connect with our peers with whom we've been working for many years to learn from and exchange best practices. So today's program will focus on how universities, including MIT, are modernizing our energy systems to improve efficiency, meet decarbonization goals, and demonstrate climate leadership strategies. And today you will hear from MIT and peer leaders from who will discuss how their campuses are renewing infrastructure to accommodate zero carbon energy for heating, cooling, and electricity. And as we were just talking about, maybe not all at the same time. That's part of the strategy. We've organized today's speakers in order of age of infrastructure, not people. And we're going to record the session to post online and share back with those not able to join us today. So without further ado, we're going to be starting with Vasso Mathes from MIT. And Vasso is our good colleague overseeing our decarbonization effort. And just take a moment to think about this in terms of, she'll be speaking to our evolution. And we're dealing with over 100-year-old infrastructure being on the Cambridge campus. Then we'll move to Sally McGarrahan at UC Berkeley. See that 1868, and then we'll move to our colleague Dave Larson at Brown. Estimate time there is 1764 at Brown when they were founded, and then we've got Ted Borer from Princeton telling us the story of from the foundation of 1746. So there's lots of stories there. That's actually prior to the founding of our own country. So Ted and Dave, you have quite the energy history there. All right, and what I'll do as the moderator, I will then introduce and share a quick bio of each speaker prior to when they start, and then we'll be accepting questions and dialogue at the end of each time. And my team will be keeping track of time. So Vasso will jump in, and then my team will signal through chat as to when you've got a couple minutes left. Actually, let me just ask specifically, Ellie or Rebecca, when will you give each speaker a warning? 5 minutes?
Each speaker has about 10 minutes to talk, so we'll give them a nudge at about the 8-minute mark to let them know how they're doing.
Okay, perfect. Does that sound good, speakers? Okay.
Yep.
So Vasso is a senior campus planner here at MIT. She's been doing a tremendous job as somebody working so closely with her, managing our decarbonization plan. She specializes in capital project management and architectural design for higher education, and she's had prior roles at Babson, Wellesley, and Harvard, and brings extensive experience in campus development. Vasso plays a key role in campus infrastructure modernization and energy system decarbonization. So Vasso, thanks for taking the time to do this, and take it away.
All right, thank you so much, Julie, and welcome everyone. I am going to be talking about MIT's decarbonization plan. We are a little bit later than most of the institutions on this call in terms of our preparedness for decarbonization. I'm sort of stuck here, trying to advance my slide, but my computer is not advancing.
Sometimes if you use the roll bar on your mouse, that works.
If that doesn't work, also, I have your slides. I can pull them up.
Thank you. I am so sorry. Something is wrong with my computer, so I can't even stop sharing. So Ellie, if you could help
I'm
me.
pulling it up right now.
Thank you so much.
So if need be, we can move on to UC Berkeley if you need to log out and log back in.
Can you see the next slide?
Yeah, I'm fine. Thank you so much, Ellie, for advancing. Okay, so MIT is really looking at getting to 2050 in a two-part strategy. There are things that we can do today to accelerate our decarbonization impact. And part of that is enabling large-scale renewable energy projects. We recently announced a partnership with other big institutions in our area to enable a solar and a wind farm purchase agreement. We are also on our campus continuing to reduce energy and doing local and impactful energy conservation measures to our campus properties. The work that I'm doing currently is really a 0 to 20 year initiative where we're studying and looking at ways to evolve our district energy system with looking into how our electrical grid is getting greener over time. As well, we need to build in resilience at MIT. So all of these things are playing into our decarbonization plan. You can advance to the next slide. So as Julie mentioned, our district central utility plant was built when MIT was first built back in the 30s. And our first source of energy was fueled by coal. Then in the 30s, we changed to oil. And in the 80s, we went to natural gas. So throughout time, every stage of evolution, we're getting cleaner and cleaner, and building a cogeneration plant in 1995, as well as off-site solar initiatives to help with our power purchase agreement. And then in 2021, we really made advanced investment in our cogen plant to really make it a state-of-the-art facility. And then our 2026 goal is to achieve net zero is we have a full success, and we think that that's happening in our 2026 initiative. And then this plan looks at eliminating direct emissions in 2050. So MIT, you can advance to the next slide, but MIT, our central utility plant produces chilled water, steam, hot water, and electricity to fuel the entire campus. So we do use natural gas, and our emissions, 55% of our carbon emissions comes from producing electricity and hot and chilled water for our campus. So you can advance to the next slide. So in about 18 months ago, we established an infrastructure planning process where we hired a consulting engineer, Affiliated Engineers, Inc., to partner with our institute to really look at ways that we can evolve our district energy system, take natural gas out of our central utility plant. And the way we organized ourselves is we had a steering committee that gave us overview and governance and insight, but we worked with, you can see at the bottom of this slide, all of the different internal stakeholders, our utility, engineering, planning, sustainability, and finance teams. And we also worked with the researchers at MIT that are working on climate initiatives. We involved ad hoc faculty and student groups. Part of our engagement was with forums similar to this. And we had test fit projects, alumni and staff work together on feasibility studies, looking at different types of technologies that could be available to MIT. As well, we talked to our peer institutions. Many of those are on the call today, as well as other institutions in and around the area. And we worked with our utility providers. So we talked to our energy, our gas, our City of Cambridge officials, Vicinity Energy, and collaborated and came together with a cohesive, well-planned approach. You can advance to the next slide. So we know that our number one thing that we need to do is reduce demand on our cup. So energy conservation measures, we looked at specifically at large energy consumers on our campus. And we looked at the cost of investments in our existing property. So this graph shows the amount of money that each of these energy conservation measures cost, and really wanted to cater the investments of our existing properties to make sure that we're effectively using our resources to give us the biggest bang for our buck. So not tackling every single thing, but really making strategic and smart investments into our properties to take that demand off of the cup. So you can advance the next slide. So we looked at a wide range of technologies, both things that are available to us today and things that might be available in the future. And we used an approach where we teamed up with industry experts, faculty and research experts, as well as our staff experts to look and do a deeper dive in a lot of the technologies that you see here on the screen. So our approach is in the works right now. We're almost ready to report, and we hope in the spring to be able to report to our community the results of this planning work that we've done. But we are well positioned to meet our 2050 goal, and I look forward to the next forum that we have where we can share the results of our plan. So that's just an overview, and more to come in the spring, but thank you.
Great. Thank you so much, Vasso. Are you okay? Perfect. All right. Well, I think what we're going to do, we're going to move on through each of the speakers. So hold your questions. But as Ellie said, feel free to start to put things in the chat, and then my team will start to sort through those. All right. Next up, we have Sally McGarrahan from UC Berkeley. She's the Associate Vice Chancellor for Facilities Services. Sally has over 25 years of experience in facilities management and energy systems. And as Associate Vice Chancellor at UC Berkeley, she leads sustainability initiatives, including the Clean Energy Campus Program, which I'm hoping my team, you can put a link to that in the chat, please, because it's phenomenal. It's a wonderful document. Vasso and I read through it, just so you know, Sally, cover to cover. And then you were so kind to meet with us as a result of that. So we'll add a link, hopefully, there in the chat in a moment. So without further ado, Sally is also responsible for the university's sustainability efforts to ensure equity in the transition to cleaner energy, which you'll hear a little bit more about in a moment. So thank you, Sally. Take it away. Thanks again for joining us.
Thank you. And you might be the only person besides the team that has read that report cover to cover. So, let me share my screen. All right. So thank you for having me here. I'm looking forward to telling you about our project and hearing about everyone else's. We call our project the Clean Energy Campus because it is a project to convert our campus from natural gas or fossil fuel to clean energy. So we always like to say why we're doing this, because it is a huge and very disruptive project. We have decarbonization goals that we are mandated to meet and feel very committed to. We have a lot of aging infrastructure. The point of the age of our campuses is such an important one. Our steam lines are failing. We have a steam tunnel that is collapsing. So there's a major investment that we need to make in our infrastructure, regardless of what direction we go in. Our studies have found that this is actually going to be cheaper to own and operate, primarily because our steam system requires so much of us these days. And we are a growing campus, and the complexity of our research is growing, and having a long-term infrastructure solution that supports that is critical. So it's important to know the context for our project. We are our own municipality. We own and operate all of our own utilities. Everything past the boundary of the core campus is ours. We have a high voltage infrastructure. We're provided with power from our local utility that lands, it's the image on the lower right, lands on the Hill campus above us and is on a dual loop through campus. And then the pink lines are all of our steam lines, and those vary in condition from having to have been abandoned to in pretty good condition. The image on the lower left is what was our steam plant. That houses some antique boilers installed in the 1950s that violate every air permit known to man when we have to fire them up. And the back block is our cogen portion that was installed in 19. It was actually one of the first cogen plants to go in. So our plant provides about 2% of the power we use at peak load on the campus. The remainder we buy from the utility. So when we started looking at meeting our carbon goals, it became very obvious very quickly that we had to deal with our cogeneration plant. That large blue segment is emissions from cogen. The others are all much smaller in proportion. So when we started looking back at this back actually in 2015, we quickly focused on originally the plan was maybe to improve cogen, and then over time we realized that we needed to move away from cogen altogether. So we are about to embark on a project to replace our cogen plant with a clean energy system. And we're doing this for a variety of reasons. An enormous reduction in our carbon emissions, an increase in resilience, because as we all know on campuses, it's key to not be held hostage by power variability. This is going to be cheaper for us over time, though it is an enormous upfront capital investment, and we think it's going to provide learning opportunities for our students. So this is what we're doing. On the left, you see our existing system, which is a combination of grid electricity for the delta between what our plant produces and what we need, a natural gas cogeneration plant, backup generators, and a little bit of solar, all work together to feed our buildings. This is what we're going to, a reliance entirely on grid electricity with some on-site generation. I'll explain about the fuel cells in a moment, but we will have solar and battery, and then a fully electrified heating and cooling plant. This is what it looks like. So we are doing this in phases. Phase one, which is the eastern half of our campus, will pick up this portion, phase two, in the future. And then phase three is the incremental add to the plant as buildings are renovated or built in the future. It's a fully electrified heating and cooling plant. You can see some of the aspects of it here. That's this underground location. It will be going under an existing field on campus that is an important open space on what's a very crowded campus. So we committed to keeping that after we build the plant. We will have an above ground thermal energy storage, which is going to be a major visual change to the campus, and a series of obviously complex distribution. And then a key factor here in this image is the geothermal wells that will be going under the plant. And these are important for seasonal efficiency. They're also important because, assuming that the IRA survives, they provide an important credit aspect for coming back from the IRA. They're a innovative technology that allows you to claim pretty serious tax credits for installing them. And costs. You cannot talk about this kind of project unless you acknowledge how expensive these are. So this is a full life cycle cost analysis that our consultant, also AEI, did for us. And it shows that over time, the clean energy investment is lower. It's broken out in these other sections as a comparison from reinvesting in the cogen system, which we call business as usual, versus this major reinvestment in the plant. And I'm sorry about that. My cat. So in each case is different. If you look in the upper left corner, this is our CapEx. So this is the first cost investment in the plant. The clean energy conversion is much more expensive. If you look at the other aspects, which are utilities, again, clean energy is more expensive. But if you look at carbon, it's a significantly cheaper system to run when you're looking at the cost of carbon over time. This is actually regulatory and straight first cost of carbon. It doesn't include social cost of carbon. If you include that, the delta is even greater. And this is O&M. It's about half the cost to run this system over time than it is to run if we were to keep the business as usual. So the cost assessment for this kind of project is very complex. A lot of data went into these, but in the end, we did find that this was a fiscally prudent thing to do, as well as a environmentally prudent things to do. Resiliency is a very important aspect, obviously, as I said. We are looking at a combination of technologies to provide the same resiliency that our cogeneration plant has done. And we actually had to island to our cogeneration plant when our utility shut off power to the region during a wildfire crisis several years ago. And we learned just how critical it is to have that level of resiliency. So there's been a lot of angst about getting rid of cogen on that front. As I said, we are going to be doing battery and solar. We have some undeveloped land we can put adjacent to the campus, so we can feed our campus from that. But that's going to be a very complicated, politically complicated thing to install. So we were at one point looking at fuel cells to replace our cogen. They turned out to be problematic. They take a lot of space. They create a lot of fire concerns. And they're no longer eligible for credits under the IRA. So they're not as financially valuable a thing to us. So we pivoted instead to keeping the gas turbine that serves our cogen plant as a backup generator when we transition off cogen. So it will no longer be able to provide, it will no longer be a cogeneration function, and that's very critical to our students, that they understand that and that we commit to not using it as cogen, but it's actually a very good backup generator. It can be idle most of the time, and we can fire it up when we need it. So Julie touched on the just transition aspects of this. That was a big driver for us. Our system, the Office of the President, required each campus to incorporate just transition planning in their decarbonization plans. And because we are far along on this, we looked at labor in depth as well as in equity overall. And we're a very unionized campus. It's very important to us and to the system that we acknowledge that and plan for that in our conversion. And so we had consultants who met with our staff and really tried to understand what this transition meant for them. And the themes we heard was they want this to be an opportunity for them to participate in new technologies and in upskilling for their future workforce. They want to be involved in the decision. They want to understand what is going to happen to their work environment and their skill sets. And that it's actually a challenging thing to ask people who have worked on a particular technology in a particular way for their whole careers to then come to a new way of working and a new relationship with the systems. And then equity, and I know I'm almost out of time. This was a broader category. This was, how does this entire project relate to the underserved communities on campus, and the themes that we found there. Again, we're making sure that the campus invests in equity efforts on campus broadly, and then more specifically around this project. So thank you very much.
That was wonderful, Sally. Thanks again. Even having seen this now presented a couple of times, I always continue to be inspired. So again, go to the link if you haven't, or note the link in your bookmarks, and I highly recommend it as a future reference. And we're just indebted for the opportunity for the exchange with UC Berkeley over time. Okay, so next we're going to transition now from the renewal of a university founded in 1868 to our friends at Brown, founded in 1764. So we've got Dave Larson with us, who's a senior energy engineer. Dave is focusing on sustainable energy solutions for campus projects. And since joining in 2011, he has led efforts to optimize energy use, improve building performance, and advance sustainability goals at Brown. Dave specializes in district energy systems and works to enhance campus infrastructure for greater efficiency and reduced emissions. So again, similar to UC Berkeley, Brown's has been a great thought partner in informing and in our own decarbonization planning. So thank you, Dave and team, for that effort. So please take it away.
All right, let me share my screen and make it a slideshow. Does that look good? Okay. So we're going to explore how Brown's reusing and repurposing some of our infrastructure as we move towards our goals. I'm not going to go back to 1764, but I will rewind about 8 years. So I think this webinar is perfectly titled. It's all about transforming. We're all constantly transforming our campuses over time, for various reasons. But and I like the old reduce, reuse, recycle thing here, but we're talking about reusing existing infrastructure as best you can towards your new goals. And so this really reduces your investment in sort of new stuff that you might have to put in, but it does require a little bit of increase in investment in engineering and testing and commissioning. So actually, one of our trade partners came up with this little graphic here. We can reduce cost and disruption in implementation time. I mean, try to get the best bang for the buck, as Vasso was talking about, and reduce that disruption that Sally mentioned. This is very disruptive, these goals, right? So that's what we're going to talk about. So my first example goes back to when our previous greenhouse gas reduction goals, our 2020 goals, which are past, but did pretty good on those. And this is on the right here, you see our Riston quad. So there's 9 dorms in here, our main dining hall, the Sharp Refectory, a museum, and our old infirmary. These were all originally fed from our campus steam system right across the street over here. So legacy system. And in the 60s, we put a high temperature hot water system in to feed 350-degree water out to the campus. And then we didn't have the money at the time to convert all of this to medium temperature hot water. There was all still steam buildings, but they over time converted the buildings to hot water locally, but they still needed to get the steam out from these hubs and then out into the buildings. So we were using some of our old infrastructure then, but with some newer pieces in place. So when we got to our greenhouse gas reduction goals for 2020, we really needed to get rid of all of our steam hubs on campus, reduce as much steam as possible. And so here we had a couple different steam hubs feeding this complex. And so the goal was, let's just convert everything to medium temperature hot water. But right now I got all these little steam lines coming through these basements, and you can see over here on the left, pretty crowded. How am I going to get medium temperature hot water lines in there, 8-inch lines, 6-inch lines, and things like that? So we were actually working with Ecosystem at the time. We still work with them quite a bit, but they took some time and they figured out there was a way to get a reverse return system in here, medium temperature hot water, the red being the supply and the purple being sort of the return, the lower temperature. Using our old steam infrastructure. So we had not only low pressure steam lines in here, but we had high pressure steam lines, which were smaller. And they devised a reverse return system here where we used the larger lines in the first part of the loop for the supply. And then we switched over and used them for the return because we had more flow on the return. And we used the low pressure steam lines, which are smaller, on the other side. So they were able to do this, and we were able to feed this entire complex from one plate and frame heat exchanger down here in Sharp Refectory, which got rid of some bottlenecks in the system up here. We ended up divorcing a couple buildings, and subsequently this building is now all electric down here at the bottom, which is kind of nice. So what they were able to do for us here, and I got to keep moving these things around here. Go back to this sort of graphic. we were able to reduce the cost of implementing the retirement of those steam hubs in that area. The cost was way less than it would have been if we had run new medium temperature hot water lines through that whole loop. The disruption was minimal. We had very little drilling, welding, dirt, and noise. And since these dorms are used year round, we have a robust summer program. That's a problem, right? You don't want to have a lot of drilling and people traipsing in and out of dorms when you have teenagers there, right? So, and it was quick and I won't say easy, but much easier than if we had run all new lines. But there was, there was something that we had to give up here. Ecosystems spent a lot of time figuring out a way to do this. How can we leverage the existing infrastructure that we have? So there was a significant engineering investment, but it was worth it. There was some inspection that we did to make sure those steam lines were adequate, including some invasive testing to actually test the thicknesses of the pipes and everything looked okay. We also had a contingency fund set aside in case we found some pipes that we needed to replace. And then pressure testing and commissioning at the end was very important. So the thermal efficiency project was 4 years total, about a year of engineering and then 3 years of implementation. But we crunched the elimination of 11 steam hubs, which probably would have taken us 15 or 20 years using our renewal program down into basically 4 years. It was very successful. So now we do have some new challenges with our new goals, and I won't go into the goals because they're kind of similar to everybody else's, but this is sort of an overview of our College Hill campus. And up here on the right is got a big air quotes here, central heat plant. There's nothing central about this. It's out way on the edge of campus. And then you may be able to make out these lines, either the high temperature hot water lines that snake out through the campus, feeding the different loads. And it's a high temperature hot water system. Before we did our thermal efficiency project, the supply temperatures would be anywhere from 320 to 350, and we had 100-degree delta T. Fairly small lines leaving that remote central heat plant, 14 inches. And we have, not as big a loads as the other institutions that are talking today. We're a bit of a smaller university, but only 14-inch line because we relied on that high delta T. Now, as you go to decarbonization and the temperatures get lower, your delta T is going to fall. So how do we, if we're still going to feed our campus from the central heat plant with these limited size lines and transition things over time to lower temperatures, how do we do that? It's not easy. Can we reuse our existing infrastructure? The other problem here is we're actually experiencing some line failures in this stretch here, where we're getting leaks, and it's very disruptive. And so our central heat plant, it would be better if it was more central. So how do we lower our distribution temperatures and work with new heat sources, our heat pumps, et cetera, still minimize disruptions on campus and in the broader community? Because those lines run under city streets. And we have easements, limited easements for the size lines that we have. But how do we also keep costs low and implement it in time for our 2040 goals, right? Not easy, but we have to spend some time thinking about it, like before. We try to find ways to reduce costs, disruption, implementation, but we'll increase our investment on the front end. So this isn't, we haven't decided to do this yet, but one of the things we're considering right now is a work in progress is we might divorce the athletics complex here and the central heat plant from the rest of the campus. We're considering this because these lines are both in bad condition, but also not large enough to serve us at the lower temperatures if all of our heat sources come from here. So now we're considering putting really more central thermal efficiency plant, thermal energy plants out on campus, also closer to our electrical infrastructure. And even if we divorce this section and get rid of this portion of our high temperature hot water distribution network, the rest of these lines in here are still functional, and most of them are in tunnels or in basements, so they're much easier to maintain. We do have street crossings, of course, and et cetera, but in general, the piping infrastructure in this area is in better shape, easier to maintain, And since we have the source of heat closer to the loads, we don't have to upsize any, well, I won't say any, but very many lines at all to do that. So key takeaways to all this. All of us want a brand new system. We all want plastic pipe in the ground and all this kind of stuff, but don't let perfection be the enemy of the progress that you can make right now. Think outside the box. And there's my timer. Okay. Think outside the box and repurpose appropriate assets where you can. It'll save you time and capital and, quite frankly, a lot of headaches too. So that's it. And I'm going to try and stop sharing my screen.
Excellent. Dave, that was fantastic. I'm sure there'll be more questions when we get to that. Okay, thank you. That was a great story. All right, now we're going to move from 1764 to our friends at Princeton, that was founded in 1746, and it's the fourth oldest university in the country. And Ted Borrow is joining us. He's the energy plant director. He's leading the energy operations and carbon reduction strategies for the university. With 39 years of experience in the power industry, including expertise in nuclear energy and sustainable systems, Ted has been a key figure in energy management and policy. He's a certified energy manager, lead professional, and a founding member of the Microgrid Resources Coalition, with a strong publication speaking record on many energy topics. I picked up on that just in our quick introduction earlier, Ted. So again, thank you for joining us. We look forward to your story. We've had eyes on Princeton since you guys announced your district geothermal some time ago. So take it away. Thank you.
Very good. See if I can handle this technology here. Y'all should be able to see that. And how do I do this? I apologize. It's just a competence thing. It has nothing to do with MIT. Just an incompetent slideshow operator here.
Okay, looks like you're all set.
Very good. Are you seeing the speaker slides, or are you just seeing the?
We're just seeing yeah, it's more of the speaker slides. So maybe you just have to do a shared present. Yeah. And I think Ellie has the slides also as backup.
There we go.
You see the whole thing?
Yeah.
Yep. All right, take it away.
So yeah, what I want to say is everything Vasso and Sally and Dave said, I can say the same thing. We are exactly on the same path, very, very similar at Princeton from the others. This is the problem that's on my desk and everybody else's. Basically, we need to save the planet, and we need to do it with good financial impact. And frankly, we're not core business. We're not education and research. We are heating and cooling and power. So basically, this slide says we can't make up the rules. We can't change physics. Everything has to happen behind the scenes, and nobody can even be uncomfortable while we do it. So that's kind of the context that we all work in. Very similar to the others. I think you heard we've got some old buildings. The top center shows our NASA Hall. It's the signature building on campus. George Washington and his troops saw this building. And the people who installed the steam lines supporting that didn't even know the First World War was going to happen. So we have steam lines. Our steam system goes back to the 1860s, 1870s. The steam lines serving this building and many others were put in 1906. So you can imagine the steel might be in okay shape, but the insulation's no good. And we're probably losing 30 or 40% of the heat that I make in the plant before it gets to the building. Like the others, we make electricity with a cogeneration system, a little jet engine. We can make about half of our peak demand, but we want to get out of that business. Basically, we need to get away from combustion. We have a slightly larger amount of solar photovoltaic by nameplate, but it does nothing, of course, when it's dark or when it's snow covered. So we need a combination of both controllable and uncontrolled, if you want, or renewable generation on campus. We make steam, both as a byproduct of our cogeneration system, as well as standalone steam delivering boilers. And then we make chilled water, both with electric and steam-driven chillers, and we have a very large amount of thermal energy storage, both chilled water and brand new hot water. I don't need to teach you how cogeneration works. It's gas turbine based, and it might be about 80% efficient on a really good day with a tailwind. There's our cute little jet engine. It's also on the stealth fighter, the FA-18 and the Blue Angels. If you're a Blue Angels pilot, you have a couple of these pushing you through the air at Mach 2. We also, as I said, have chillers, thermal storage, cooling towers, which henceforth, you can't call this a cooling tower anymore. You need to call that an energy throw-away machine, because that's really what we're doing. We're taking heat out of the campus with our chillers, and we're throwing it away back into the outdoor environment, instead of what each of us, I kind of think each of us alluded to, storing that energy that is in excess in the summer and saving it and reusing it in the winter. And I think a really important meta concept for all of us in this sustainability game is, where is there waste, and how can I use that waste for my own benefit? And really, that's what each of us are talking to you about. There's our first thermal energy storage plant, storage tank. It goes back to 2005. A very, very attractive financial project, because we can buy inexpensive power at night and avoid the purchase of very, very expensive power during the day. It always stays full. This one's full of chilled water, or basically ground temperature water. And we have another couple of them that are both hot water and chilled water. Different picture, same story as the others. We need to get to carbon neutrality. We picked 2046 instead of 2050, because that's the 300th anniversary of the institution. But again, we're really all on the same path. And to put a finer point on it, we also want a continuous downward slope from present till our carbon neutrality date. We don't want to just assume do nothing, do nothing, do nothing. Oh, magic happens on the very last year. The major bulk of our work is going to be steam to hot water conversion, and using the heat pumps and geo-exchange to complement that, as well as on-site solar renewable and off-site solar, wind, and potentially nuclear. In the very end of the game, we'll need to come up with a little bit more trickery. It may involve biofuels. We're really very carefully trying to avoid the use of offsets, paying someone else to clean up their act while we continue to live a dirty life. If you took one slide from this presentation, here's the recipe to save the planet vis-a-vis Princeton. We're tightening up every building on campus. If it's existing, one at a time, when we do a gut and renovation or even a major renewal, we're going to improve the building envelope. It may involve windows or air sealing or insulation or HVAC scheduling. We're replacing the district steam system with district hot water. Like the other speakers, this is a non-trivial project. We're putting 13 miles of district hot water system in a campus where we've been burying utilities for 270 years. So there's a lot of stuff on the ground to be avoided. The only place we can't put the new hot water system is where the steam system is, because you picture everybody in that building wants continuous hot water. So I need the hot water working before I can remove the steam line. We've built a electric powered heat pump facility. We call it the Tiger, but you can come and see it. It's in operation today. And I've just issued the 13th month report on the thermal performance, which is amazing. It's truly amazing. I'm really impressed by it. Thermal storage, we talked about a little bit. And then seasonal storage is geo-exchange. Our friends at Stanford have pleasant weather all winter and all summer. They don't really need seasonal storage. They just need daily. But those of us in the Central Atlantic and Northeast, anywhere from Princeton and north, certainly, we have very hot summers, we have humid summers, and we have very cold winters. So we need to capture the summer's heat and store it. So we're doing that in a geo-exchange system. We're already supplying more than 10 and probably about 15% of the electricity that the university needs through on-site solar PV. We're never going to get to 100%, so we need to buy renewable energy from off campus as well. This is what we're doing today. On the right-hand side, we're burning stuff, delivering heat to the campus. And then on the left-hand side, we're adding more energy to this system and removing heat from campus and throwing it away. So you say, well, gosh, you really ought to combine those two systems so you could be a lot more efficient. So that's what we're doing. We're putting a heat pump in the middle, but the heat pump isn't enough to make the steam conditions of today. So we're making hot water. The slide says 150. That would be an unusual day, although we can. Normally, we supply about 140 to the campus buildings, and we have about 15% of our campus converted from getting heat via a steam system to getting heat from a district hot water system. This is a slide that if you don't get it, it's going to become very, very familiar to you down the road. It's a 3-year period. What you're seeing is every hour for 3 years. The red is heat delivery, the blue is heat removal. And what you can see is the curves are very similar, except they're 180 degrees out of phase. So basically in the summer, I need to remove a lot of heat, and I don't have a lot of heat I need to deliver, just domestic hot water, and the losses from our steam system. So if I eliminate the losses from my steam system, the blue curve, heat removal, and the red curve, heat delivery, they're almost an exact overlap from each other. So we're right in the sweet spot where our energy recovery from the summer should be really close to our energy need during the winter. This is a picture of a drilling rig on the left. We need to drill about 1,000 we've drilled about 1,000 geo-exchange wells. We have about 1,000 more to go. That'll take us another decade, but we're way ahead of our building hookups. It's messy, it's super invasive, it's noisy, it's not a pretty thing, and it's once every century or every century and a half. So my unsubtle comment is get over it. This is the way we're going to store energy going forward. And once we've tidied it up, you won't know it for another century and a half. On the right is a heat pump. It looks a lot like a chiller to me, an industrial chiller. There's a cartoon or an artist rendering of our Tiger plant. Come see it. It looks exactly like that. It's almost amazing. In the center, you can see our chilled water, our new chilled water thermal storage tank. And just hiding behind that and the Tiger plant is our our new hot water thermal storage tank. If everybody does what Princeton and the other campuses are doing, we're going to need a lot more electricity, and wintertime will also be a peak demand period for electricity. This is just iconic of if it's standing still on campus, we're probably going to bolt a solar panel to it. Over parking lot, over parking decks, building tops. Basically, if the architect doesn't have a reason not to, we're putting solar on it. But like I said, we might get to 20, 25, maybe 30%, but I'm certain not more than that in terms of on-site renewable energy production. I think I should land it there. And what you've seen is really a lot of common threads between each of our presentations.
That was excellent, Ted. You had some good ones there. I think your get over it sticker, is it a sticker at Princeton you've created? Because I think we're all going to have to learn how to manage lots of disruption.
What I'm telling people
over
is
time.
When I point to the geo-exchange drilling, that's what saving the planet looks like.
Yeah.
That's what it takes to get
Fantastic.
over, get past a century and a half of combustion.
Yeah. Excellent. So some before we jump into some questions, I think just some commonalities that I've heard, and please add to these. We're all asking the same questions. I think we've all been working together, not necessarily directly the people on this call, but these universities, we've all been working together for over 2 decades and more on sustainability and climate issues. And this is not a race. And that's been the beauty of finding these collaborations and be able to learn from one another, leapfrog where we can, share communication strategies, and these energy interventions. So we've been asking the same questions. We're all managing age-old infrastructure from 108 years old to 278 years old. We've all inherited multiple energy eras, if you will, and old steam lines and aging infrastructure and buildings. We're all seeking creative phased interventions and engaging with students, staff, and faculty alike. And we're all seeking creative financial strategies as well. Again, we won't cover all of that on this call, but those are areas I know that dialogue that's happening with Ivy Plus groups at various entities. So with that said, there are a couple of questions that are very specific, but before I jump into the specific questions, I'm curious if there's anything that stuck out to the panelists in terms of other something that made you think of how much we have in common or a distinct difference with your campus. Anything to add?
I noted two things. I want to learn more about UC Berkeley's freezer farms, and I was really impressed by Brown's reuse of existing infrastructure. As Dave noted, that's really, really expensive, hundreds of millions. And if we can reuse existing infrastructure, hats off.
And I'd just like to reiterate the fact that most of our buildings are heated by steam, high temperature steam, and the thermal losses that we have in our distribution of that steam is considerable. So just by turning our steam dependence into a hot water dependence already gets us a lot of the way there in terms of our carbon emissions and our energy use. It takes a lot of energy to produce steam, less energy to produce hot water. So I think all of us are really looking at that being the transition of our systems.
I just add one
go ahead,
thing.
Sally.
I think we're all going to need a sticker that says "deal with it," because these are really disruptive projects, and what we need to do, or we're planning to do, is communicate the need for it. But in the end, acknowledging that this is a communal effort with response needed from everyone to make them successful, I think is an important aspect.
And that becomes such an opportunity for exchange between all of these groups and other peers, is how we're Vasso and I and some others on our team have been talking about using some even in case examples on our own campus where there's been large interventions and quite disruptive in some of the labs, but it's been managed so smoothly. And so how do you scale that up, and what can we learn from each other in terms of how those disruptions are managed so it can become smoother for those that come after us in these transitions? So we'll continue to have that conversation together. Well, there are more questions that were being asked than we can actually get to. So thank you all in the audience today. So one of the questions, I think there's a good one. They're all good. One thing that I think we're all managing, keep in mind in terms of commonality, while some of us are in different climate zones, we're all dealing with the changing climate. And one of those is going to be in extreme heating, cooling as that changes. And we're all dealing with the increase in demand from AI and data centers. It's coming up in many meetings throughout each week now. So are there any examples from any of the campuses where you're using, the question specifically is, are you using or do you plan to leverage AI in some way, for example, for peak shaving or load shifting? And how might you decide on those services or energy management? So I know on the MIT front, if folks could add, there's a great article about the AI interventions we've been looking at with researchers. And if you could add that, and if you have others from other institutions, please signal that to us. But Ted, it looks like, did you want to start on that one?
Yeah, we've been doing what we'll call economic dispatch, really since August of 2003.
Okay.
You wouldn't call it AI, but it's a very intelligent system that takes into account weather data. It takes into account our history. It's actually operating on the screen behind me, but it takes into account all the different assets you have, and based on real measured data, figures out what's the most economic configuration. We don't fully automate it, and that's on purpose. We still want it to go through a thinking human brain. because safety's first and everything else is subordinate to that.
So it's a partnership with AI is how I'm hearing you say it.
Yeah, it's a
In a
very
way, yeah.
intelligent system, but it's expert guidance as opposed to automation.
Okay, great. It looks like Sally started to answer in the chat. Anything you want to add, Sally?
No, I didn't finish my sentence about Stanford. They have a very sophisticated control system that they've been generous enough to share with us. So we're going to be learning from them for implementing the level of control system we need for this new system.
Great. Any, are we good, Dave? Anything? Okay, Vasso. All right. There's there's more comments in we won't be able to get to everything, but the whole point of these webinars is to be able to circulate. We're capturing so everyone knows all of the questions that are being asked, and it will actually just continue to inform all of us in terms of the kind of questions our audience has. So we'll share questions back to the panelists after this meeting. There's, I want to get to two more. One's very specific to Sally on, and then I want to go to a general one. There's a question here, because I think we'll all benefit from this, Sally, is can you say a little bit more about the projects creating an engaged and diverse community towards the energy transition on campus? As we know, we're all going to have to navigate that carefully moving forward.
Yeah, it was an interesting exercise because as a facilities person, you really do tend to think about the nuts and bolts. And as we engaged more with the community, we realized how many concerns they have with it. So just very quickly, some of the things that we need to do is make sure we're engaged with our tribal representatives on campus more than we are currently. We're going to be digging up a lot of land, some that has never been dug before. There's very little of that, but there are some chunks, and making sure we engage with them in that process. They want to make sure that we have a broad curriculum that's integrated throughout the campus that relies on the data and the information coming from this plant so that all aspects, all types of students can benefit from what we learned from this plant. In labor, they asked that we look at an apprenticeship program that would bring underrepresented groups into the opportunity to learn from this plant, whether they continue to work for us or elsewhere. Mm-hmm. And that make sure that we're paying attention to the impact of the project on the broader community, whether we're creating good jobs, whether we're really reducing air pollution in our community. So it's sort of all over, and I'm happy to, if anyone wants to ask me directly about it, I can provide more detail.
That's great. Again, there's so many good questions here, so apologies that we can't get to all of them. I think we end on this one with just a minute or so to go, but there's a question here from our good colleague in DC who's asking, except for Princeton, I'll never forget, Ted, when you guys set that 2046 goal. There's a lot of commitment to tigers and 2046 with the Princeton spirit coming out there. So it says, except for Princeton, everyone is looking at a 2050 goal, right? There's a 2046. Is anyone else looking at a race to move faster in the spirit that the university community has the knowledge and capability to lead the broader society? So I picked this one because this is a very tricky question, being deep in our decarbonization process here from all of what you heard today. Sally, go ahead.
I just want to say I should have mentioned our schedule. We plan to turn off cogen in 2030. And then phase 2, we plan to finish by 2035. So we expect to meet our carbon goals by then, funding allowing. Okay. So we're pretty confident about phase 1, which gets us 80% reduction. Phase 2, we still have to find the money for.
And I'd like to answer that question because MIT is really looking carefully at the New England grid and where that electricity is coming from. So I think there's a lot of unknowns right now in our region about how green the grid is. And in order for us to really be making a difference in terms of our emissions, our carbon emissions, we have to ask the question, where are those generations getting their electricity from? And we can't really make a commitment to turn our plant off when we are not exactly sure what the risk is for importing that electricity. So we need to be really careful about the timing of that. So even though we say it's 2050, it gives us time to prepare for those changes in that transition. But obviously MIT wants to do this as fast as we can, but we want to also look at our grid and what those emissions impact, our area. So it depends. But regulations for Cambridge is 2035 in a sense. So.
Yeah. Vasso, thanks for mentioning. I mean, keep in mind, we only have so much time to cover today, but each of us, from Princeton to Providence to Berkeley and Cambridge, we're all managing city and state various regulatory environments and pace at which our grids are moving. So all of us, we didn't get to it today, are navigating a strategy that cuts across campus, city, state, and federal level structures. What we're sharing today is the interventions on our campus, but it's all contextual. Dave, it looks like you want to say something.
I'll
and then
just
Ted, final word. Go
briefly
ahead.
say, yeah, we're finishing up an update of our roadmap, which we're all going to be doing every few years as we go because things change. And if we get approval for this, we'll get to 90% around 2034. So similar to what Vasso was talking about, get your best investments up front. That's what we've been focusing on the last year. So
Excellent. Ted, any final comments?
No, this was beautifully done. We all know, we know how to save the planet. It's really getting permission to do it. And really that requires getting funding to do it. And I think what each of us is saying, even if we haven't explicitly said it, is, seeking the best financial path to getting where we know how to get to already, right? That's the challenge. And I'd say each of us has probably found that. It's been very thorny, but we know how to do it, and we know how to do it with good financial stewardship. And that's the tricky part on everybody's campus.
Excellent. And, again, thanks to the trust that's been built between all of our campuses over many decades, that opportunity for transparent sharing is so valuable. So thank you all for joining us today. Again, for those on the call, we will capture all of these excellent questions into a document. It's already been started. We'll share those back out with Ted, Sally, Dave, and Vasso as well, because I think it'll trigger some really interesting discussions. And stay tuned. And also, Ted, Sally, and Dave, we're going to be back in the spring with updates from MIT. We'll share the link if you're curious as to our updates, and please do the same, because we had quite a coverage of people on the call today. All right, so thanks everyone, and if we don't see you, have a great holiday season, and we'll see you in the new year for an update from MIT. We do not have that date set yet, but we will share that out to those who joined us today in the new year. All right, thank you. Take care.